Section 3.2 goes over slope of a line. Your slope is your rise over your run, or the change of y over the change of x. With these, especially if you're looking at a graph, you're always going to be going up or down and then to the right. So with this, looking at these two graphs, you see that your textbook does it a little bit differently, but however, I find that if you go up or down first, that will give you the sign on your slope. So if you're going up and to the right, it's going to be positive. If you're going down and to the left, it's going to be negative. Down and to the right, it's going to be negative. With these, again, it's just your rise over your run. So it's the change of your vertical points or your y values over the change of your horizontally, your x values. If we look at the first examples, we're just using the graphs to find the slopes. So for example A, you have the point A and you have point B. A is the point 0, 3, B is the point 2, 0. So going from left to right, we're going to be going down 3, so that's going to be a negative 3, over to the right 2. So that slope is negative 3 over 2. For B, you're looking at this line from left to right. You have two ordered pairs on there, 2, 1, and 6, 3. From the 2, 1 to the 6, 3, we're going to go up 2, and we're going to go to the right 4. So our slope for this one is 2 over 4, which is simplified to be 1/2. With these fractions, you always want to give your simplified fraction for your slope. So it wouldn't be the 2 over 4 that you would give for your answer for that one. You would just give the 1/2. For B, you have two ordered pairs that are 0, 0, and 4, 2. For this one, you're going up 2 to the right 4. So again, your slope is 2 over 4, which is 1/2. You can also start by looking at these lines and seeing if they're going up from left to right, it would be a positive slope. If it's going down from left to right, it would be a negative slope. So like for example A, if you're just looking at the line from left to right, that line is going down, so that's going to be a negative slope. For B and C, that line's going up, so it would be a positive slope. So with some of these, you can use your slope formula, which is just y2 minus y1 over x2 minus x1 in order to get your slope. You want to remember with this, if you subtract your y values and you get 0 on the top of your fraction, your slope is just 0. If you get 0 on the bottom of your fraction, so when you subtract those x values and you get 0, your slope is undefined. You want to keep this in mind while you're doing this. Another thing you want to keep in mind, whatever you take for your first y value that you're using, so your y2, your x2 has to come from the same exact ordered pair that y2 came from. You can't switch them up. So if we look at your next example, it tells us that the line goes through the ordered pairs 2, 5, and 6, 3. We're going to use the formula for slope to find the slope of this line. So remember, this formula for slope is y2 minus y1 over x2 minus x1. If I label that first ordered pair 2, 5 as x1, y1, my y2 or my x2, y2 is going to be the 6, 3. So this is going to give me 3 minus 5 over 6 minus 2. The 3 minus 5 gives us negative 2. The 6 minus 2 gives us 4. So this simplifies to be a slope of negative 1/2. For B, we have the ordered pairs -2, 3, and -5, 1. So just for the sake of switching this up, I'm going to use the second point as x1, y1, and the first point as x2, y2. So like I was saying, you can rearrange the points. So the first point can be your second point, the second point can be your first point, doesn't matter. But if you take your x2 as -2, your y2 has to be the 3. It has to come from the same ordered pair. So again, we're going to use that slope formula, that y2 minus y1 over x2 minus x1. So this is going to give us m is equal to 3 minus -1 all over -2 minus -5. Those two negatives next to each other turn into positives, so we're doing 3 plus 1, which is 4, and -2 plus 5, which is 3. So our slope is just 4/3. For C, we have a line that goes through the ordered pair -6, 4 and the origin. You want to remember that that origin is the ordered pair 0, 0. So my x1 is going to be -6, meaning my y1 is going to be 4. My x2 is going to be 0, my y2 will be 0. So I'm going to use my slope formula, y2 minus y1 over x2 minus x1. This is going to give me 0 minus 4 over 0 minus -6. The two negatives turn into positives. 0 minus 4 is -4. 0 plus 6 is 6. If we simplify this, we're going to get -2 over 3. When you are working with horizontal and vertical lines, these are when you have that slope of either 0 or that slope of undefined. Think about it. If 0 is in the top, our slope is 0. So our y values would have to be the same. So if we look at example A, we have -3, 2, and 4, 2 for those two ordered pairs. So if we did this as x1, y1, this one is x2, y2, this is going to give us a slope of 2 minus 2 all over 4 minus -3. The 2 minus 2 is 0. The 4 plus 3 is 7. So our slope for this one is 0. So any horizontal line, automatically your slope is 0. So if it goes through the y-axis and is a straight line, that's a horizontal side-to-side line, our slope is 0. Now, if you have a vertical line, think about this one. Your x values are the same. So when you subtract those x values, you're going to get 0 in that denominator. So if we did this as x1, y1, this 1, -4 as x2, y2, we're going to have -4 minus 2 over 1 minus 1. This is going to give us -6 over 0. You cannot have 0 in the denominator. So your slope for a vertical line is undefined. For the next part, we're just working with parallel and perpendicular lines. Parallel lines have the same slope, different y-intercepts. Perpendicular lines have the opposite slope and reciprocal of the slope. So we look at example 4. It tells us line L goes through the origin, so it goes through the ordered pair 0, 0, and is parallel, so it has the same slope to the line through -2, 3, and 4, -5. Find the slope of line L. So since it's parallel, it has the same slope. So we find our slope of that original line, which is going to be -5 minus 3 over 3 minus -2. Those two negatives turn into addition, and we get -8 over 5. So if it has the same slope, our slope of the line that goes through the origin is negative 8 over 5. For a perpendicular line, it has the opposite and reciprocal of those slopes. So we are going to look at the last examples, and it tells us that the line L contains the point 1, 6 and is perpendicular to the line of negative 4, 1 and 3, negative 2. Find the slope of line L. So our slope for this line, that's negative 4, 1 and 3, negative 2, we're going to do negative 2 minus 1 all over 3 minus negative 4. So this is going to be negative 3 over 7. So opposite of that is positive, and reciprocal would just be 7 over 3. For example 6, we have to determine whether negative 3, 2, negative 2, 1, or negative 2, negative 1, 4, 1, and 3, 4 are vertices of a rectangle. So we can label this first point A, second can be B, then C, then D. We're going to find the slope of all of these. So we're first going to find the slope of AB. So we're going to do negative 1 minus 2 over negative 2 minus negative 3. This gives us negative 3 over, not 5. This becomes positive 1. So that's negative 3. The slope of BC is going to be 1 minus negative 1 over 4 minus negative 2. So 2 negatives become positive, so that's 2 over 6, which is 1/3. For the slope of CD, what you can do, 4 minus 1 over 3 minus 4. 4 minus 1 is 3 over 3 minus 4 is negative 1. That's negative 3. And then the slope of DA, we're going to have 2 minus 4 all over negative 3 minus 3. So that 2 minus 4 is 2 over negative 6, which is negative 1/3. Sorry, this is a negative 2, so positive 1/3. So if you see here, you have two lines that are the same, those are parallel, and then the other are the opposites and reciprocals, so this definitely is a rectangle. So A, B, C, D are a rectangle.